So another thing is I would like to comment is that for the transportation, okay, for design all kinds of vehicles, the most important thing, of course, is to reduce the resistance. Okay. So the first great invention is wheel, because rolling friction is much smaller than kinetic friction, the sliding friction. So wheel can help you to reduce a lot of frictional force. Okay, so that's one of important invention in the early stage of the human civilization. Okay, and of course, every invention depends on the needs and the situation. In fact, for example, you probably know that for those early civilization, almost all of them invented the wheel. Okay, like the in China, in ancient Greek, in ancient Egypt or Babylon, all these old Asian civilization invented wheels. But civilization in America, like Inca and Maya, they didn't invent wheel. And can you think about why? Inca people live in Andes mountain, and Maya people lives in jungle. So practically, they wouldn't see the need to use the wheels. Basically, cannot use. Okay. So other civilization more or less leave some plain area. Okay. So they see the need of the wheel. Okay. So you can see that that's one of the great invention to reduce the frictional force by using the wheel. So because rolling friction is much smaller than the kinetic friction, and then further people can further reduce the frictional force by introduce very flat uh, surface, like highway. Even the rolling friction also depends on the roughness of the surface. So flat surface can still reduce a lot of friction. So that way we have the highway. And also the best is of course the railway, the steel track with the steel wheel, both of them are very smooth. So the frictional force is very small. Train is actually a very effective way for the transportation. Okay, and now people can even think about, since any contact will introduce the uh, uh, frictional force, right? Even the rolling on the very flat surface, you will have some frictional force. So to further reduce the frictional force, of course, you can think about, if there is no contact, then there will be no frictional force. That's magnetic levitation, high-speed rail. Okay. Maglev. So I'm a fan of high-speed rail. Okay, so I was looking at this news several years ago. The first commercial maglev train has been operated in Shanghai, China. It's only quite short, maybe I think 17 miles or 20 miles or 30 miles. I don't remember. It's a very short line. Okay, but it can reach. I forgot the exact number, but I think the commercially operated operation speed is more than 300 miles. per hour. And the testing speed reached to 400 miles per hour. And you probably know what is the speed of the airplane, usually. 500 miles per hour, so almost as fast as the airplane. So it's very promising stuff, high-speed rail, okay. HSR, I'm HSR fan. Because the most important thing is that to run airplane or car, okay, so far you need to use petroleum oil, right? But train now, almost all the trains are run by the electricity power, which is generated by power plant. A power plant use coal and nuclear material. Both of them are we have more coal and nuclear material available to use than the petroleum oil. Okay, so it has a good, big advantage. So in fact, if we use more of the railway system, by the way, it's more effective. Okay, you can put a lot of cars in the same train with the same engine, so it's much more effective. So you can reduce your dependence on the oil. Okay. So that's why, like some of the country try to establish some extensive high-speed railway system. Okay. I'm talking about China. And of course, in here, people argue that train doesn't fit the lifestyle here, right? Because we like to drive cars. It's more convenient. It's more freestyle. But in fact, the railway can fit it into the American living style. For example, you can think about it. You can design larger train. So you can even put your car here. So it's possible, but technically it's not. You just need to make it a wider train. Okay. So that way you can think about long distance travel can be very convenient. You can just drive for the high speed rail, so let's say if you drive to Houston, takes some high speed rail, and only take 2 hours, you will be in Orlando. Okay, and then you can drive your cars to travel in Orlando. That's very convenient, right? But of course, there is a balance between the high speed rail and it costs a lot of money, so still need ways the technology develop to the point that we can reduce the cost. But again, technology is one side of the problem. The other side of the problem is what is our vision. Okay. In fact, the train, the railway, was the most important transportation in this country. It's just intentionally destroyed by some other industry. In fact, they bought all these train company and bought all these railways and just let them rot there. So they can pave the way for airplane and cars. And behind airplane and cars, of course, it's the oil industry.
Good stuff.
Okay, but anyway, oil cannot last forever. Okay, it will. So for the cars now, people also think about like electric cars. Okay, but it's different idea. Oil, people estimate that it can last for maybe 50 more years, and coal maybe 150 years, and fusion efficient nuclear power maybe 300 years. And so far, we don't have the fusion nuclear power. but if it can be put into the actual use, it's almost infinity in the time. Okay, now let's go back to air resistance. So mostly we think about dropping something in the air. So my first question is, does falling object accelerate forever? The answer depends on what kind of situation you're talking about. In the vacuum, so is it accelerate forever? Should be until it hit by something. Okay. In the air, is that true? No. Because air resistance, we say that depends on the velocity. So initially, you have a very small air resistance. But when the object is getting acceleration, is accelerating. So the speed getting larger and larger. So the air resistance getting larger and larger. So finally, at some point, the air resistance should reach the value of the gravitational force or the weight. So to that point, it will not accelerate anymore. Okay. So any object, in fact, when you drop into the air, it will go through the acceleration process and finally reach some terminal velocity. After that, it will drop with a constant velocity. So you can see that how do we determine the terminal velocity? Okay. So we can use this factor to determine the terminal velocity. The air resistance, we call it R, okay, and that has to reach the value of the gravitational force, Fg or W. So that's a condition to determine the terminal velocity. Okay, because R is a function of the velocity. So in this equation, you can solve for velocity. Okay? So let's put this discussion into a precise mathematical form. So actually, what we say is that the drag force, the air resistance, depends on the forces, density of the fluid, cross-sectional area A, velocity V, and coefficient C, determined by the shape of the object. So to calculate the drag force with air resistance, it's given by the multiplication of these quantities with 1/2 coefficient in front, just some convention. And please note that the dependence on the velocity is v squared. Okay, so it's highly dependent on the velocity. And the terminal velocity vt happens when a equals to 0, or this force, drag force B, equals to the weight mg. Okay,